Jim, I know we've talked a lot about artificial intelligence and machine learning, especially in the industrial and manufacturing space.
Mm-hmm.
And I can think of no one else in the world who could better talk about its practical applications, or maybe lack thereof, of AI and machine learning in the space. Can you tell us a little bit more about it, how you feel about it, and where you see it going in the future?
Wow, that's a loaded question, Dave.
It is.
I wouldn't say I'm the world's foremost authority. Thank you for the kind words there, but there's a lot of people that I've learned from, and I'll reference a couple of those people. But I think there's a lot of hype out there right now that probably is a little bit unwarranted, honestly. I think it's going to be a little bit more difficult to get at that value than what the hype train will have you believe. And what I mean by that is you got to remember, artificial intelligence and machine learning, really all it is just math behind the scenes. And the algorithms have been around, most of them, since probably the 50s, 60s,
Yep.
up to about the 80s, right? The issue is we didn't have the data sets or the computing power to really, make use of them. And now we do. We can actually, make use of them. So now it's, what do we do with them? And it's funny, I've even got a couple of machine learning fails, I think, from YouTube.
Mm-hmm.
It would say American football topic, and the first video would be baseball, greatest home runs ever. And you're thinking, okay, YouTube probably does this about as well as anyone,
Yeah.
and they can't get it right.
Mm-hmm.
Does that mean it's bad? No. I just think it means it's going to take a while for us to get it perfected, and we're going to have to take it all with a grain of salt. Now, let's take that to an industrial space. You get a machine recommendation, kind of like the football, baseball analogy, and you have something, because a lot of people are saying, oh, we'll just let the machine figure it out and, let that control our process.
Mm-hmm.
Well, sometimes you make that decision and it can be disastrous, literally
Oh, yeah.
disastrous, right? From a
Mm-hmm.
safety perspective, or, a bad product perspective, or something like that. So I think there's going to have to be some humans involved. So I think at times it's going to be somewhat limited as to what we can do with it.
Mm-hmm.
Now, with that said, do I think it's a bad thing that we should shut down and never try? Absolutely not. And we're invested in it. Ben and I have done a couple of projects where we've looked at some things, we've looked at some different platforms, and we've experimented. We're trying to figure out so that we can be the insight for our customers. This name was picked with a purpose. We really want to help our customers figure out, okay, when do we just need to do our first principles analyses versus when do we need to do something much more advanced that we can't see, by the human eye. So a couple analogies. This is one, John Anthony's of Envoy Development. He's a good friend of mine and been a great business mentor for me. And he's been around a long time. He works predominantly in the pulp and paper industry.
Okay.
He's got some stuff in mining and some other industries too. But he really takes time series data and does a lot of statistical analysis on it. He's looking for correlations and looking for when things go, out of their normal range, which is I always tell people it's kind of like a sentry looking over your data and telling you can't trend 50,000 tags or 100,000 tags, right? So this is kind of looking at that and being a sentry for things. So he's got two great analogies that are very related that I think, if you think about it from this perspective, this is really the way to think about it. Is he said usually the algorithms will pick up human rules first,
Yep.
right? So you think about, like he's got this one, he's a little guy like me, he runs, he's like me, he runs. Actually, I don't run as much as I should. But he said, let's say I come up with a rule, Jim, that my normal weight's 150 pounds,
Mm-hmm.
right? If I weigh 153 or greater, I run 3 miles a day.
Mm-hmm.
If I'm 150 to 153, I run 1 mile a day. If I'm under 150, I don't run at all. And I run that against a machine learning algorithm, what's the thing it's going to find? You weigh
The
more?
more you run, the more you weigh.
The more you run, the more you weigh.
Yeah.
Is that true? It's a human-based rule in how we react,
Yep.
right? And if you look at a lot of our modern process plants, a lot of what we're going to see is a human and how they react to a process that's not running correctly, right? There's a lot of human noise. And as a case in point, you know, he calls me one day and he said, so I just had this customer call me and said, hey, I want to do a study between machine speed and the number of brakes we have. And he said, you know, I kind of felt like I knew the answer to the question, but I went ahead and pulled the data because I really wanted to take an unbiased look at it. And so he said, you know, what he found was a rule that he would have expected. So what do you think happens? I'm going to ask you this. What do you think happens when the paper machine starts to break more? They start to have more downtime. What do you think they do with the speed?
They turn the speed up because they are trying to make up for the breakdowns?
It's actually the opposite. They slow it down because they don't know why they're breaking.
Okay.
And they want to make waste less fast.
Okay.
Right? Because what happens is you get a break and it goes down into a pit and you can recycle it most of the time.
Okay.
You know, it depends on what kind of stuff you're making. You know, if it's coated and, you know, if it's not coated, it depends, you know, but there's a cost. They'll recycle a bunch of it, but maybe not 100%. So the initial thing you'll find is, oh, to have less brakes, you speed up, right? That's not really true. That's not really the cause.
No.
Right? It's a correlation. And machine learning and all these other algorithms are great at finding correlations. The problem is as humans, we're the ones that really need to find the cause. Okay? And because the machine and the math doesn't really know the difference between correlation and causation. All right? Is that a bad thing?
No.
As long as we don't say, okay, this is gospel and this is what we have to believe. Right? I think what we have to do is then let a human take a look at it and say, okay, there's a bunch of correlations. Yeah, we knew that, we knew that, we knew that. That doesn't matter, that doesn't matter, that doesn't matter. Because we did one, let's see, when was it? It was probably over the summer. And the stuff that I found most correlative, they said has nothing to do with it. Like, we don't even control that, has nothing to do with our paper machine quality. It was in a paper company. And so therefore, I said, well, let's take that out of the model completely, right? Because it just muddies the water. So, you know, that's a big thing we have to do is once we get the correlation back, then a subject matter expert has to look at it and say, does this even make sense? Can we make sense of this? Does this have any correlation, or I'm sorry, any causation to the actual thing we're trying to do? Okay. So those are a couple of analogies that I typically try to steer people with.